Hey guys, today we're going to look at how to solve rational equations. Now before we do that, we're going to review how to add, subtract, multiply, and divide rational expressions. Now a rational expression is basically fractions. So if we're going to add and subtract fractions, what we first need is a least common denominator, or the LCD. Now I put here in blue that the LCD is typically the denominators multiplied together, unless they already have a factor in common. Now I also wrote to keep these denominators factored. It makes it easier to work out and simplify when necessary. So before we add anything, we're going to have to figure out the LCD. Now, and in order to figure out the LCD, it's useful to factor. So x squared plus 2x can be factored to be x times x plus 2. Now our least common denominator here, we have this x and this x squared. X squared is basically x times x. So that means that the factor x is part of the least common denominator. Now in this one, it's squared. So if you ever have a common factor in the two fractions, then we take the one with the highest exponent, which in this case is squared. And then we also have this x plus 2. So that will also be part of my least common denominator. Now when we're adding, what we need is to make sure that both of these denominators have the same denominator, which is the least common denominator. So here in this first one, we have x plus 1 over x times x plus 2. The least common denominator is x squared times x plus 2. So I'm going to need to multiply x to this denominator so that it equals to the least common denominator. And that means I'll also have to multiply the numerator by x. Whatever we do to the denominator, we have to multiply to the numerator. Now let's move on to the next term, which is 3 over x squared. If we look at the LCD, we have here both the x squared, but we're missing the x plus 2. So I'm going to have to multiply by x plus 2 to the denominator, and the same goes in the numerator. So now for the numerator, we're just going to distribute everything, and we're going to make the entire thing over the least common denominator, since now they both have the same denominator. So I'll work that out piece by piece. For this first one, if I distribute this x, I get x squared plus x over x squared times x plus 2. Plus, now here we have the 3. So I'm going to distribute this 3 with the x plus 2. So we get 3x plus 6 all over x squared times x plus 2. See how the denominators are the same. So we can write this as one fraction. This would be x squared plus x plus the other numerator, which is 3x plus 6, all over the least common denominator, which is x squared times x plus 2. Now we just combine like terms in the numerator. So this would give us x squared plus 4x plus 6 all over x squared times x plus 2. And this would be my answer. Now let's look at subtraction. We have x plus 3 over x minus x minus 1 over x minus 2. These denominators don't need to be factored because we can't. The least common denominator is when we multiply these together. So that would be x times x minus 2. So remember that we're trying to rewrite both of these denominators so that it equals to the least common denominator. For this first fraction, we have x plus 3 over x. In order to rewrite this denominator as the same, I would need to multiply by x minus 2. And same goes in the numerator. Minus, now we have here x minus 1 over x minus 2. Here we have the x minus 2, but we're missing the x, so I'm going to multiply by x here, as well as in the numerator. Now, when we're subtracting, we have to keep in mind that we're subtracting everything that is to the right of that subtraction symbol. So we have to be careful and make sure that we keep parentheses to make sure that we distribute that negative. So let's work out this first fraction. We're going to distribute x plus 3 with x plus 2. And that would give us x squared minus 2x plus 3x minus 6 all over x times x plus 2. Minus, now I'm going to distribute this x, and that would give us x squared minus x all over x times x minus 2. Again, we have the same denominators now, so we can put all of this together. And again, notice how I left everything to the right of the minus sign in parentheses, so I don't forget that I'm going to need to distribute that negative. So this would give us x squared minus 2x plus 3x is plus x minus 6. Minus, now I'm going to distribute this negative, x squared plus x all over the same denominator, which is x, oops, this is a minus, times x minus 2. Now we just combine like terms in the numerator. These x squareds would cancel. Then we have x plus x, which is 2x, over, 2x minus 6, sorry, I forgot the minus 6, over x times x minus 2. And we can just leave the answer like that. Let's try a couple more. Before I can subtract, I'm going to need to find this common denominator. This denominator can be factored to give you x times x plus 7. And this x minus 8 cannot be factored, so we leave it. The LCD is just all of these denominators multiplied together. So x times x minus 7 times x minus 8. So now we want to rewrite everything so that it has the same denominator. For this first fraction, we have 3 over x times x, I don't know why I put minus, plus 7. I'm going to need to multiply x minus 8, since that's what I'm missing from the LCD. And now minus, we have 4 over x minus 8. I'm going to have to multiply the other factors that I'm missing. I'm missing both the x and the x plus 7. So I'm going to multiply by x and x plus 7, both to the numerator and the denominator. Now we're going to distribute. So I'm going to distribute this 3, which would give us 3x minus 24, all over x times x plus 7 times x minus 8. Minus, now here we have, this is 4x, which I'm going to multiply with x plus 7. So 4 times x is 4x, like I said, and 4x times x is 4x squared plus 4x times 7 is 28x, all over x times x plus 7 times x minus 8. Now we distribute the negative, so we get 3x minus 24 minus, now I'm going to distribute, so 4x squared minus 28x all over x times x plus 7 times x minus 8. And finally, we're going to combine like terms and rewrite this numerator. So we have negative 4x squared. Then 3x minus 28x is minus 25x minus 24. All over x times x plus 7 times x minus 8. And this would be my final answer. Let's look over here. we have 4 over 3x plus 3 plus 2 over 5x squared plus 10x. So let's factor. 3x plus 3, I can take out the 3, and I will get 3 times x plus 1. Here I can factor out the 5x, and that gives me x plus 2. Now our least common denominator is everything multiplied out. When you have multiple numbers, you can multiply that together. So 3 times 5x is 15x. Then we have the x plus 1 and x plus 2. Now we need to rewrite these fractions. So the first one, 4 over 3 times x plus 1. What we're missing is the 5x from the 15x and the x plus 2. So I'm going to multiply both the numerator and the denominator by 5x times x plus 2. Plus. Now over here we have 2 over 5x times x plus 2. So to make this denominator the same as the least common denominator, we need to multiply 3 times x minus 1. And so we need to do the same thing to the numerator. Now we distribute everything from the numerator. So 4 times 5x is 20x times x plus 2. And I'll continue multiplying this in a bit. All over 3. Well, 3 times 5x, so this will all be over the least common denominator. So let me just fix that. So 15x times x plus 1 times x plus 2 plus 2 times 3 is 6 times x minus 1 all over 15x times x plus 1 times x plus 2. Again, we have everything with the least common denominator, so we can just put these numerators together. I'm going to go ahead and distribute this 20x here and the 6 here. So 20x times x plus 2 is 20x squared plus 40x. Plus, now I'm distributing the 6, 6x minus 6, and everything is over my LCD, which is 15x times x plus 1 times x plus 2. Now we combine like terms, so we get 20x squared plus 46x minus 6 all over 15x times x plus 1 times x plus 2. And that would be my final answer. So that's adding and subtracting. Let's now have a look at multiplying and dividing. Multiplying and dividing fractions is actually more simple than adding and subtracting. So we don't necessarily need an LCD when we're multiplying or dividing fractions. Since when you're multiplying fractions, you multiply numerator with numerator and denominator with denominator. And when you're dividing fractions, you multiply by the reciprocal of the second function, or copy, change, flip. So this is how it works. What we're going to do first is we're going to factor each rational function completely. So x squared minus 2x minus 8 can be factored to x minus 4, x plus 2, over x squared minus x minus 6 is x minus 3, x plus 2, times, now over here we have x squared minus 2x minus 3, which is x minus 3, x plus 1, all over x squared minus 5x plus 4 is x minus 4, x minus 1. So when we're multiplying, basically it's all of the numerators multiplied together and all of the denominators multiplied together. So what we can do now is cancel any common factors in either the numerator and the denominator of either function. So here we have this x plus 2 in the numerator and the denominator that can cancel. Then we have this x minus 4 here in the numerator and here in the denominator. And since we're multiplying everything, we can cancel these as well. And then we also see that this x minus 3 with this x minus 3 can also cancel since one is in the numerator and the other is in the denominator. So the only thing that we have left is x plus 1 in the numerator over x minus 1 in the denominator. And this would be my final answer. Now with division, I would wait to cancel until we have flipped the second fraction. And this is what I mean. So let's factor everything completely. The numerator, x squared minus x, can be factored to be x times x minus 1. The denominator, x squared plus x minus 2, is x plus 2, x minus 1, divided by x to the third plus 5x squared plus 6x. First we can factor out an x, which gives us x squared plus 5x plus 6. So I have this x, and then x squared plus 5x plus 6 can be factored to be x plus 3, x plus 2, all over x plus 3. Now when you're dividing, you can cancel from each individual side first if you'd like. Like here I can cancel this x minus 1 with this x minus 1. But I would not go across just like I did here because this is division, not multiplication. Here I can also cancel the x plus 3's. So now what I'm going to do is I'm going to rewrite this. We have x over x plus 2 divided by x times x plus 2. And there's nothing left in the denominator. So if you like, we can write this over 1. When we're dividing, we have to copy the first fraction, so x over x plus 2, change to multiplication, and then flip the second fraction. So this would be 1 over x times x plus 2. And now you can cancel across anything that is common in the numerator and the denominator. So here we can cancel out these x's. And we're left with 1 over x plus 2 squared, since there's 2 of them. And this would be my final answer. Let's try a couple more. So first we start off with multiplication, so we're going to factor everything. So x squared minus 16 is a difference of squares. So this would be x plus 4, x minus 4, over x minus 9, times, now here in the numerator, I can factor out a 4, and I would have x minus 9, all over, and here I can factor out a 5x squared, and I would be left with x minus 4. Now since this is multiplication, everything is being multiplied straight across. So we can just go ahead and start canceling things that are both in the numerator and the denominator. So I can cancel these x minus 4's. I can also cancel these x minus 9's. And now what's left in the numerator is 4 times x plus 4 over the 5x squared. And this would be my final answer. Now we're going to do the same thing here, but this is division. So I'm going to wait to cancel things across the division symbol until I copy, change, flip. So in the numerator, we have 3x squared minus 6x minus 24. I can first factor out a 3. And that would give me x squared minus 2x minus 8. I'll continue factoring that in a bit, but I'm going to just factor little bits at a time for now. In the denominator, I have this 2. Everything is divisible by 2, but I don't want to keep factoring with a negative, so I'm going to factor out a negative 2, and I can also factor out an x. And that would give me x squared minus 3x minus 4. Divided by, here when we factor negative 4x minus 8, I can factor out a negative 4, and that will give me x plus 2. All over, here I can factor out a 2, and that would give me x squared minus 2x minus 3. Now let's finish factoring everything that we left. Here in this numerator we have the 3, and then x squared minus 2x minus 8 can be factored to x minus 4, x plus 2. All over negative 2x, and then x squared minus 3x minus 4 can be factored to x minus 4, x plus 1. Divided by, the numerator is already completely factored, so we just need to keep factoring this denominator, which will give us 2, and then x squared minus 2x minus 3 can be factored to be x minus 3, x plus 1. So now before, like in the previous example, I already started canceling some things from each individual fraction before I flipped, but if that is confusing, that's okay. Once you've completely factored, just go ahead and copy, change, flip, and so turn it into a multiplication problem, and then we can cancel everything all at once. So that's what I'm going to do here, just so you can decide what you prefer. So I'm going to copy this down. So 3, x minus 4, x plus 2, all over negative 2x, x minus 4, x plus 1. Change to multiplication. Negative, oh, sorry, I was about to just copy it down again. We have to flip the second fraction because we're going to multiply by the reciprocal. So 2 times x minus 3, x plus 1, all over negative 4, x plus 2. Okay, so now we can just start canceling things out. So I see here that I have these x minus 4s that will cancel. I also have x plus 2, both the numerator and the denominator, that I can cancel. I also have these x plus 1s that will cancel. And then we see here with the numbers, we can also simplify this. We have a 2 here and a 2 here. The 2's will cancel. Then we have this negative in the denominator times this negative in this denominator as well. And when we multiply negative with negative, it's going to make it positive. So now we write down what's left. In the numerator, all I have is this 3 and then the x minus 3. And in the denominator, I have this x and 4. So x times 4 is 4x. And this would be my final answer. Now let's look at how we solve rational equations. Now when we're solving rational equations, we can solve this in two ways, and that depends on how the rational equation is written. This one, for example, can be solved by cross-multiplying and solving the resulting polynomial equation. However, if your rational equation has where you have rational expressions that are added or subtracted, then you may need to find the LCD, combine, and then cross-multiply. However, I'll show you a shortcut for that. Now, when we do this, when we're cross-multiplying and we're solving for rational equations, we have seen with rational functions that there are such things as excluded values, which are the values that make the denominator equal to 0, because that would mean that that rational function is undefined. So what we do first is we figure out what the excluded values are of the rational expressions that are given. And that way, when we find the solution, if the solution gives us one of those excluded values, then that is not an actual solution and actually called an extraneous solution, which just basically means a solution that doesn't necessarily work. It's not a solution of the actual equation. So that's what we're going to do first, is to figure out what the excluded values are. So that way we know when we solve this rational equation, if we get that as an answer, it is not actually a real answer, but rather an extraneous solution, an extra solution that doesn't actually work. So Here, when we look at this denominator, we have x minus 5, and if we set that equal to 0, we get that x cannot equal to 5. And with 2x minus 10, if you do the same thing, we would have to add the 10 and divide by 2, meaning that x cannot equal to 5 is the same excluded value for this part of the rational equation. So this is our excluded value. So now what we're going to do is we're going to solve by cross multiplying. So we multiply 3x plus 7 with 2x minus 10. And this is going to equal to x minus 5 times 5x plus 17. We have to distribute everything on both sides of the equal sign. And we get 3x times 2x, which is 6x squared, minus 30x plus 14x minus 70 equals to 5x squared plus 17x minus 25x minus 85. Now let's combine like terms on both sides of the equal sign. So we get 6x squared minus 16x minus 70 is equal to 5x squared minus 8x minus 85. Now what we have here is basically quadratics. So we want to make this equal to 0, so that way we can factor and solve for x. So I'm going to subtract this 5x squared. I'm going to add this 8x. And I'm going to add this 85. And what I get here is x squared minus 8x minus 15 is equal to 0. I'm sorry, plus 15 is equal to 0. And this we can factor. This is x minus 3, x minus 5 is equal to 0. So now when we set each one equal to 0, we get that x is equal to 3 and x is equal to 5. But we saw here that x cannot equal to 5. So this is my extraneous solution, therefore not being a real solution. And the actual solution is just x is equal to 3. Now let's look at when we have a rational equation where we cannot just cross multiply. As you can see here, we have these two rational expressions that are added first. So we have 2x minus 9 over x minus 7 plus x over 2, which is equal to 5 over x minus 7. First of all, the excluded value here would be that x cannot equal to 7. Since that's what we have here in the denominators, and if we set it equal to 0, that means that we have a vertical asymptote in those particular rational functions. So that is not a solution. Now the LCD in this case would be 2, because we have this 2 here, times x minus 7. And I even made a note here just in case if you forgot. If you ever have a hard time finding the LCD, make a list of all the factors in the denominator and put them together. So we have x minus 7 and 2 and then x minus 7 again. So my LCD is just x minus 7. Now what I wrote here is that first you will have to combine the fractions on the left side of the equation, so that way we can cross multiply. However, there's a little shortcut. If you want to bypass this step and not have to combine fractions, what you can do is multiply the entire equation by the LCD. So that's what I like to do because I think it's a lot easier to work out. So we have here 2 times x minus 7, that's my LCD. And I'm going to multiply it by the entire rational equation that I have there. So 2x minus 9 over x minus 7 plus x over 2 equals 5 over x minus 7. Now I'm kind of going to do this the long way just so that you can see how this works. If I multiply everything, this is what I would get. 2 times x minus 7 times 2x minus 9 over x minus 7. Because remember, this is over 1. So when we're multiplying fractions, we just multiplied numerator with numerator, denominator with denominator. So what I did was 2 times x minus 7 times 2x minus 9, that's the numerator, over 1 times x minus 7. Plus 2 x minus 7 times x all over 2 is equal to 2 x minus 7 times 5 over x minus 7. And now what I can do is I can start canceling. I see here that these x minus 7's cancel. These 2's cancel. And these x minus 7's cancel. When you multiply the LCD to a rational equation, what ends up happening is that all the denominators will cancel. So what we're left here is just 2 times 2x minus 9 plus x minus 7 times x is equal to 2 times 5, which is 10. And this is much easier to solve. We can now distribute the 2. So this would be 4x minus 18 plus x squared, when I distribute the x, minus 7x is equal to 10. Combine like terms here, we get x squared minus 3x minus 18 is equal to 10. Subtract the 10 to make it equal to 0 so we can factor. And this gives me x squared minus 3x minus 28 is equal to 0. This can be factored to x minus 7 times x plus 4. And if we set each factor individually equal to 0, we get that x is equal to 7 and x is equal to negative 4. But we got here that x cannot equal to 7. So this is the extraneous solution. And x equals negative 4 is my actual solution. Let's try a couple more, just to make sure. We have here 8 over x plus 3 is equal to x plus 1 over x plus 6. So first we need our excluded values, and that's just by setting each denominator equal to 0. So x cannot equal to negative 3 or negative 6. Now I'm going to cross multiply. 8 times x plus 6 is going to equal to x plus 3 times x plus 1. Now distribute. We get here 8x plus 48 is equal, distribute here as well. We get x squared plus x plus 3x plus 3. Now we can combine like terms on the right side. So we get x squared plus 4x plus 3. Since this is a quadratic, we want to make it equal to 0. It's easier for me to move these two terms over to the right. So I'm going to subtract this 8x, and I'm going to subtract this 48. And we get x squared minus 4x minus 45 is equal to 0. And now we factor. This is x minus 9 times x plus 5. And we get two solutions of x is equal to 9 and x is equal to negative 5. Neither of these are my excluded values, so that means that both of these solutions are our solutions. Now let's look at this last one here. We have 1 over x minus 2 plus 1 over x squared minus 7x plus 10 is equal to 6 over x minus 2. I need my LCD, so I'm going to need to factor this. This is x minus 2, x minus 5. So a couple things here. We know our excluded values is 2 and 5. Now my LCD is going to be x minus 2, x minus 5, since those are all of my factors. And now I'm going to take this entire equation and multiply it by the LCD. So we have x minus 2 times x minus 5 multiplied with 1 over x minus 2 plus 1 over x minus 2, x minus 5 is equal to 6 over x minus 2. Now, if you want to reduce the amount that you're writing, when you're multiplying the LCD with everything, what I do is I look at what would end up canceling. Like here, I'm going to multiply this x minus 2 and x minus 5, and the x minus 2 would end up canceling with this denominator. So really, the only thing I'm multiplying is the x minus 5 with 1. So that is x minus 5. Plus, now here when I multiply x minus 2, x minus 5 with this next fraction, both of these factors would end up canceling. So we're just going to multiply 1 with 1. And that's going to equal to 6. And here these x minus 2's would cancel. So the only thing I'm going to multiply 6 with is the x minus 5. And now we solve. So this gives me x minus 4 is equal to 6x minus 30. We want to get all of the x's on the same side, so I'm going to subtract the 6x over, and that gives me negative 5x minus 4 is equal to negative 30. Add the 4, we get negative 5x is equal to negative 26, and then divide the negative 5. A negative over a negative just cancel, so we get that x is equal to 26 over 5, which is not any of my excluded values, so this would be my final answer. And that's solving rational equations.